right, I'm going to go through an energy page that we did in class just to kind of review conservation of energy and then a couple of the things we might calculate with it. So this is a skateboarding person. They're at the top of a ramp and then they're going to travel downward. So we're going to fill in the blanks using conservation of energy thinking. And then we've got a couple of equations up here just to remind us how we, oops, hang on a second. My lights went out. Okay, there we go. Just to remind us how to calculate kinetic and potential energy, we're going to use those in just a minute, okay? We really don't need them for this first part because we're going to remind ourselves about conservation of energy, okay? So at this top point, we're given that our potential energy is 300 joules. We are not moving at this point. All of our energy is due to position, okay? And when we're at the top point of a ramp or a roller coaster or different scenarios that we've used in our classes, all of our energy is going to be potential. We can also use that to give us our total energy because our mechanical or our sum of all of our energy always equals kinetic plus potential. We've always got some combination of kinetic and potential that's making up our mechanical. This is a number that does not change, okay? It's conserved and it stays the same for every point in our scenario. So if this potential energy is 300 and at this point I don't have any kinetic energy, say we're imagining we're starting off here at this point, okay? Then PE of 300 plus KE of 0 means that I have a total energy or a mechanical energy of 300, okay? And then I can use that same 300 at every point. You see the 300, 300, 300, okay? At this point, partway down the ramp, so this kind of looks more like halfway to me, but, I'm just eyeballing that. We're given that our kinetic energy is 180. We know our total is 300 because we just got that from this top point and using this relationship. So we can take 300 minus 180 and solve for our potential energy. We're just taking this minus this and solving for our potential energy there. These two add up to 300. Then at my bottom point now, I don't have any height, so all of my energy is kinetic. My potential energy here is 0 because this is 0. And I'm moving along, and all my energy is kinetic. Again, this total equals this because it's really this plus this, but it's 300 plus 0 equals 300, okay? So with conservation of energy, you want to remember at your top point where you're not moving yet, where all your energy is your energy of position, all your energy's potential, that also gives you your mechanical energy total, okay? Because that value plus 0 is that value. And then as we move downwards, our energy is going to be transforming. It's going to be changing from potential to kinetic. So our potential is going to be going down. Our kinetic is going to be going up. We see that here. Potential's down, kinetic is up. And then as we move into our bottom portion where we don't have any height, all we have is movement. Now all of our energy has transformed into kinetic. Still the same mechanical energy total because energy is a quantity that is conserved, okay? Then really quickly, if we wanted to calculate some velocities, okay, so they want to know how fast was the skater traveling here and here. Let me flip over to the back right quick. If I use my kinetic energy equals 1/2 times m times v squared equation, I want to solve this for v so I can get a way to solve for a velocity. I'm going to divide both sides by 1/2 times m. That way these cancel out. I got v squared on this side. On this side, I'm going to flip this 1/2. I'm dividing by a fraction, so that's like multiplying by the reciprocal. So I'm going to have a 2 on the top times kinetic energy divided by mass. And in order to get velocity, my final step is to take my square root of both sides. That gives me v by itself, because this is just v times v. So if I take the square root of that, I'm going to get v. And then I'm going to have the square root of this. So going back to the other side, I'll just write that up here in case we forget. I can just use this equation in these questions here. So how fast were they traveling at position 1? We know our kinetic energy there, and we know we have a mass of 24 kilograms. So we're going to put those into this equation. 2 times 300 divided by 24. I got to take the square root of all that. So let me do that right quick in the calculator so you can see it. The way I would do it, just so you don't get confused, 2 times 300 divided by 24. That gives me 25. I know the square root of that is 5, but I'm going to do it. I'm going to put it in to my calculator and show us that. Okay. And on your calculator, you want to look for something that looks like this check mark. That's where you go to take a square root. Okay. Don't try and do too many functions at once in your calculator. And then this one, how fast are they moving at position 2? It's the same type problem, except you're using this kinetic energy of 180 now instead of what we have here. So I've got 2 times 180 divided by 24. So 2 times 180 equals, divided by 24 equals 15. And then I'm going to take my square root of 15. I got 3.87. So at that point, my velocity is 3.87 or 3.9. So see, you started off at 0 with velocity because your kinetic energy here was 0. As we're traveling down the ramp, at this point, we're at 3.9, so our velocity's increased. And then at this point, we're at 5, so our velocity's increased even more. Where your kinetic energy is greatest, your velocity is also going to be greatest because it's 1/2 times m times v squared. The last question on here, how high off the ground were they at position 3? So we can use our potential energy here and our equation and solve it for h. Again, this one's a little simpler because it doesn't have a square root in it. I've just got m times g times h. If I want to solve for h, I'm just going to divide both sides by m times g. And that gives me height equals potential energy divided by m times g. So going back to the other side, my potential energy there was 300. Divide that by 24 times 9.8. Again, with the calculator, this one's a little easier to do with parentheses, but just always be careful with that. Don't give your calculator too much to think about. I've just got one simple set of parentheses, and I got 1.28. So they gave us one height here at 0.2. This height is 1.28. So this was, like I said, this is a little less than half of this. This is almost 1.3 here. Okay, so that's just a quick rundown on some conservation of energy, calculating energies, and then different quantities using these equations.